Hey everyone, it's Colin. How's it going? Over the decades, we've seen computers go from kilobytes to megabytes to gigabytes of RAM and beyond. This time, let's figure out just how much Windows actually needs. Okay, so in a previous episode, I went and tried to install Windows 10 on the oldest hardware that I had available. I won't spoil the ending to that one, but if you want to watch it, it's up top. Go ahead and click on that one. Now, in the comments of that video, a lot of people went and said how they thought RAM was an issue with some of the struggles that I faced in getting that project going. Now, ultimately in the video, I explained what I thought really was the underlying problem with trying to get Windows 10 running on older hardware, but it did get me thinking about, well, would RAM really have even been a factor at all? And if so, what's that minimum amount that Windows would have needed to actually get up and running? This time around, I figured, you know what, we could actually put that to the test. We can try various versions of Windows, starting with Windows 10 and working our way backwards to see what's the actual minimum amount of RAM that Windows requires to function. Now, I'm not talking about what the minimum recommended amount is by Microsoft. I'm talking about what's that threshold where the OS refuses to even boot up. To keep things kind of on an even playing field for all these versions of Windows, I'm not going to be using physical hardware for this test. I'm going to do all of them in virtual machines. There's two major benefits to doing it that way. First is that it's going to be the same virtual hardware configuration for all of the operating systems, so you don't have to worry about processor architecture or hard drive, anything like that, being a potential factor during this testing. The other upside to using virtual machines for this is that I get very granular control over the amount of RAM that I actually give to Windows. On physical hardware, you can only buy memory modules in specific sizes. With a virtual machine, I can dial it down to the megabyte so we can actually get some really interesting information. So let's get started. All right, so I've got a Windows 10 virtual machine going on here. I should note that all of the ones we're going to be testing with are running the 32-bit version of Windows, again, just to kind of keep things on a level playing field. Now, this is Windows 10 1803. This is the latest version of Windows 10. I don't have any additional applications installed in this. However, it is kind of the base install, so you can see we've got all sorts of the garbage applications and games and all that stuff. So we'll start with system info, pipe, find string, and we can see how much RAM is currently allotted to this virtual machine. So I've given it 2 gig of RAM to start. I figure it's a decent amount. Available physical memory is how much is left, and then virtual memory, which we'll talk about as we kind of go along here. Now you can see some of these numbers will actually match what we've got going on in Task Manager, but you get a little bit of additional information by doing it through the command prompt here. Plus, this is a little bit faster and cleaner to look at. But you can see 2 gig of RAM here. 1 gig is in use by Windows, so we can tell right away how much it wants to use off the bat, but how much we can pare that down to is a good question. For those curious, I am running this on a Core i7-7700K. I'm only giving these machines one virtual processor, like one socket, one core. So that's going to get around any issues with multi-core that some operating systems may not be able to handle as well as others. Again, I want to try and keep this as even and fair of an experiment across all the different versions of Windows as I can. So let's go into here. I'm going to shut the virtual machine down. We've got our VM shutting down here. So let's go back into show all. Will it repopulate? Yeah, okay. So let's try knocking it down to 1 gig of RAM to start and see where we get. Well, of course, we have to work on updates. So surprisingly enough, the machine actually boots with 1 gig of RAM, which I guess isn't terribly surprising considering some of the low-end systems that ship with Windows 10 on them and how relatively small amounts of RAM are being put in them. I'm looking at systems like those $200 kind of netbook replacements, the ones with the Celeron or Atom CPUs. A lot of those only come with like 32 gig of flash, but also only like 2 gig of RAM. So if people are buying computers and they're actively being sold with that little RAM, I would imagine Windows 10 could maybe at least halfway decently handle that. But let's see what the actual utilization looks like now. Okay, so some definitely different numbers this time around. It still shows our only 1 gig of RAM, but the amount of available physical memory has shrunk to 400 meg from the 1 gig it was at before. We can get kind of that visual representation by going into Task Manager here and looking at the RAM. Windows seems to have shrunk how much it's actually using, which is interesting. It seems to be doing a pretty decent job at trying to minimize the amount of RAM that it's actually using in this VM. We're actually shrinking down to about half of that 1 gig. But let's take it down another notch and see just how far we can go. All right, so we've knocked it down to 768 megs of RAM. Let's see what we get this time around. Okay, definitely less available physical memory this time, but Windows 10 is actually still functioning like halfway decent in terms of performance. I'm really rather surprised about that. It seems to be, kind of hitting a threshold here. Like we're not a whole lot below the 500 meg like we were before, but I'm kind of surprised. Actually, it's still shrinking again. It seems to be paring down even more. I don't know. Let's take it another notch, see how much farther down we can get, huh? Oh, seems to be taking a bit longer to log in. We might be hitting a wall here. Oh, but it made it. Wow, okay. Yeah, we're definitely running up against the limits of what Windows can do. Only 80 megabytes free. So we're sitting at about a little over 400 megabytes of RAM in use, which, considering how much people trash talk Windows 10, I'm kind of surprised about. That's really reasonable in terms of how much RAM this uses. Now, of course, I don't have any applications in use right now, so this machine would become practically unusable when it comes to actually doing anything with it. So I guess it's time to go another notch down, huh? All right, 384 mega RAM. This is going to be interesting. Wow, we made it to the login screen on 384 megs of RAM. And we made it to the desktop. This is rather surprising. So, I just find it fascinating because everyone talks about how bloated Windows 10 is and all that, but it at least booted. Now, it's very unresponsive. Like, it took me a few clicks there to get the start menu to show up. Okay, now it's there. Wow, 40 megabytes of RAM free out of 383. All right, here we go. Let's try 256. Yeah, start menu. A little laggy, but it's still there. Oh, come on. You can do it. Oh, it's really struggling. Just trying to bring up the command prompt. Okay, CMD, command doesn't want to work. Can I get... Oof. Okay, so here's where... Come on. Here's where we're running up against a wall. I think we're hitting the page file incredibly hard right now. And on real hardware, this machine would perform likely way worse than it even is now. So this is probably a great opportunity to talk about the page file and what it is and what it does. The page file is part of what's called virtual memory. And it is exactly what it sounds like. It's kind of a virtual allotment of RAM for your computer. The point behind it is RAM is incredibly fast, but in terms of the amount of storage you get out of it, it's fairly expensive, right? It is way cheaper to have hard drive space, storage space, than it is to have RAM. So that's why we generally see a relatively small amount of RAM in computers compared to the amount of hard drive space that they have. Now, what happens if you want to try and run more programs than you have available in physical RAM? Well, that's where virtual memory comes into play. It can take parts of physical RAM that aren't being used. Maybe it's a program that you've got hidden down in the taskbar, that you've got minimized, you're not actively working in it, so it's just kind of sitting there idling. the system can take those memory resources from that program, and instead of leaving them in RAM, it'll write them out to a file on the hard drive just to have them available. And then that frees up RAM for other programs to load or for other programs to be able to perform better. So it's a way to effectively have more RAM in your computer than it otherwise physically has. The problem is that there's a major performance penalty for hitting virtual memory because hard drives, even SSDs, are still way, way slower than RAM, physical RAM actually is. When you reach a certain threshold where you've got a lot of programs in virtual memory on the page file, which is what Windows calls that particular file that all the contents of virtual memory gets written to. When you've got a lot of programs hitting the page file, obviously your hard drive becomes very, very busy. And because the hard drive is way slower than RAM, and you've also got this multi-step process for getting information into and out of RAM, well, you end up with a major performance hit. The computer overall just slows way down, which is why one of the best investments you can make on your computer is to put more physical RAM in it if you're experiencing slow performance. A faster CPU will only get you so far, but generally more RAM is only going to help because you're doing less operations against virtual memory. You can see under the committed number here, this 2.7 gigabytes. The 2.7 is the full amount of memory available to the computer. So that's a combination of physical RAM and the size of the page file. So you can see how huge 2.7 the page file is compared to the amount of physical RAM in the system. That 2.7 is physical RAM plus page file. It's still managing to work, which I'm really surprised by. Now that said, I want to crank this thing lower until we get it to a point where it no longer works, and we can call that our minimum. Okay, so let's go straight to 128 megs of RAM, and we'll see if it chokes. No blue screen or anything yet. Oh, there we go. Okay. Yeah, it can't do 128 meg of RAM, kind of like I was suspecting, so let's just go ahead and power it off. Previous was 256. How about 192? Split the difference. You know when you're having trouble loading Task Manager, something serious is up. Can we hit the performance tab? There we go. Wow, yeah, it's using almost all of its RAM, but Windows has managed to get down to a physical allotment of 180 something megabytes. You'll notice that the page file has actually increased. Last time it was 2.7 gig. We've moved up to 2.8 gig on the total committed. Another interesting thing to note here is this amount of compressed memory. It's not a whole lot, but it's still a decent proportion compared to the in-use amount of RAM. Memory compression is a relatively new thing in terms of modern operating systems. I mean, it's, as a concept, been around for quite a while. But it's kind of like the same thing as compressing files in your hard drive. You know, you can take a bunch of files and put them in a zip archive, and the total archive size will be smaller than what the total amount of all those files were individually. It's kind of the same thing with memory. If you've got RAM utilization that can be shrunk down, it'll go ahead and do it. It will use some CPU cycles in the process of doing that. But on modern computers, CPUs are so powerful, it's really worth that slight performance hit to try and compress memory to get the most out of how much physical RAM that you actually have in the system. It's doing a pretty decent job here considering how much it has available and how much it still needs to use. But in systems with more applications running and more amounts of RAM available to them, memory compression can actually have an even bigger effect. So memory compression is overall a very good thing. So 128 didn't work, 192 worked but was super painful, 160. Oh wow, 160 mega RAM, we made it to the login screen. Now, I'm not going to waste anybody's time, yours or mine, trying to log in and get into Task Manager. I'm just going to go ahead and shut this guy down. Oh, come on, update and shut down. So this is where we can start to get into weird numbers, right? How about 140 mega RAM? Whoa, 140 mega RAM. This thing still gets me to the login screen. Okay, let's take it down another notch. 128, 140, how about 136? Starting to split some hairs here a little bit. Okay, 136 did not work. It's stuck at 136 in VMware. Wonder why. No, okay, so now it's at 140. Maybe I can only go in 4 meg allotments on VMware. That would be interesting. I didn't know that before, but anyway. So 130, 138, really? Is that the, can I not do? Yeah, so it takes me back to 136. Okay, so there's your answer. 140 megabytes is the bare minimum that you need to get the system up and running into the desktop. Now, of course, it's completely unusable otherwise. And the only reason that it didn't take absolutely forever to load is because the page file for that system is sitting on an SSD on my computer that's really fast. It's an NVMe drive. On a traditional like laptop or desktop with a mechanical hard drive, I don't want to know how slow this would have been, even with a modern CPU like the Core i7 that I'm throwing at it here. But in any event, 140 megs is a really interesting result. Now, I suspect other older versions of Windows will go even lower. That's where we're going to head next. Okay, since we have a baseline for Windows 10, and I'm going to go out on a limb and assume that of all the OSs we're testing here, Windows 10 is going to be using the most. I think we can spare some of the grind on these other OSs and start to really kind of cut to the chase. So I've got Windows 8 up here. It's 8 32-bit, just regular 8.0, not 8.1. It does have all of its other updates and everything that it needs, but it again is just kind of a base install. I've given it 2 gig of RAM to start. You can see it's actually using about a similar amount. It's using about a gig of RAM, so it has a gig of RAM free. Let's go straight to 512 and see what this thing does. Okay, I just had to make sure. 512 meg of RAM, no problem. Update and restart. Oh, this again? When are there not updates for Windows? Let's go straight to 192. Yeah, I know it's below the recommended minimum. I don't care. That's the whole point. Okay, so Windows 8 making it happen at 192 meg of RAM. Yeah, why not? Let's do it. Let's go straight for 140. See what we can hit here. At least see if Windows 8 can do the same minimum as Windows 10. No! Oh, wow. So Windows 10 can do 140 meg of RAM. Windows 8 cannot. Was 152 a number that it's going to like because of that whole 4 meg increment thing? Yeah, it'll do 152. A whole whopping 12 megs of RAM. Nope. Nope, doesn't want to do 152. Wow. Kind of surprised by this. 160? No. It won't even do 160. 168 seems to have worked. Okay, 164 is not working, but 168 did. Interesting to see that Windows 8 actually needs more in terms of bare minimum RAM than Windows 10 does. And everyone talks about Windows 10 being this horrible bloated mess. Well, compared to Windows 8, that's apparently not the case. Windows 8 doesn't work nearly as efficiently as Windows 10. Now, of course, yeah, there's lots of crap that Windows 10 installs compared to Windows 8, but in terms of just the base OS, clearly Windows 10 is going to have a better time on computers with lesser amounts of hardware specs than Windows 8 did. So that's an interesting result. So far, Windows 10, 140 megabytes is the minimum. Windows 8.0 32-bit is 168. Okay, up next, Windows 7 32-bit. This one is or should be fully patched. Windows 7 SP1. And just like before, Windows 7 here, I'm starting with 2 gig of RAM. Available physical memory is still a gig. So that's been a very interesting, consistent number between all these versions so far. Windows 7, Windows 8, Windows 10. But here's where things are going to get really interesting. So 140 for Windows 10, 168 for Windows 8. 140 so far is the number to beat. Let's see if Windows 7 can do it. No. Windows 7 can't do 140 meg of RAM. Okay, so I've been screwing around with Windows 7 for a while now. I think I've got it to its bare minimum, so let's set it to that and fire it up. So I managed to get Windows 7 32-bit SP1 with no additional applications, pared down to all of 192 mega RAM. So these results are just really interesting and kind of undermines what a lot of people traditionally think about these newer versions of Windows. I mean, Windows 7, a lot of people are still big fans of, especially if you go through the comments on that Windows 10 video that I did installing it on the old hardware. Lots and lots of people saying that Windows 10 sucks and they don't like it. And yeah, I agree that there are some UI changes to Windows 8, Windows 10 that aren't as clean and nice to use as Windows 7, but that doesn't necessarily mean those newer operating systems are any worse or any more of resource hogs than something older like Windows 7 is. If anything, it actually proves that these newer operating systems have been getting more efficient. It took 192 mega RAM just to get Windows 7 to boot, whereas we can get Windows 10 to boot on the same virtual hardware with only 140. Now, I know that it's still kind of splitting hairs and that sort of thing, but if it's that big of a difference between an older OS and a newer one, imagine just how much more efficient the operating system is going to be when you actually start running applications and putting it under load. It shows that they are actually putting an effort into making the operating system better, to run better on lower amounts of hardware compared to previous OSs. When I was testing Windows Vista, the minimum amount of RAM that I could get it to boot with was 224 megabytes. And even then, there was hardly anything left in free physical RAM, and the machine was still pretty slow. When I tested with XP, it booted fine and ran without any problems with as little as 128 megabytes, and I was even able to ratchet it down to 96 megabytes. It still booted, it still got me to the desktop, but it's so slow as to be pretty much unusable. We're talking it takes like a minute to register a mouse click. But still, Windows XP able to boot and run at 96 megs of RAM when just the next version Windows after it required 224. But then it goes down to Windows 7 at 192, Windows 8 clocks in at 168, and then Windows 10, perhaps the biggest surprise of all of them, only 140 megabytes of RAM to get Windows 10 32-bit to boot and get you to the desktop. Of course, these are all just standard vanilla installs of the operating system with all of the security updates available as of the time that I filmed this. No other applications running, so it's not really indicative of what real-world use would actually be like. I have no doubt that if I tried to run programs and be productive with an operating system with that little of RAM, I just wouldn't get very far at all. But it does show some really interesting numbers and kind of the progression of Windows from just almost 2 decades ago until now. I can only hope that maybe this trend will continue with trying to make operating systems leaner and more efficient to better utilize what hardware resources are available. Clearly, operations of the page file have gotten better in years since. It seemed like Windows 10 and Windows 8 were definitely making better use of the page file, and the machine stayed fairly responsive, whereas like with Windows XP, about 5 minutes ago, I asked it to bring up Task Manager with 96 mega RAM so I could screenshot it. I'm still waiting for it to come up. So, you know, it's really curious as to how this progression has gone, but it just goes to show that, you know, the complaints that we have about operating systems, sometimes they're only skin deep, and maybe the underpinnings are actually in better shape than we expect. Proof positive with Windows 10. Anyway, if you like my stupid computer experiments episode here, I would appreciate a thumbs up. Be sure to subscribe if you haven't already. You can follow me on Twitter and Instagram at thisdoesnotcomp. And as always, thanks for watching.